Okay, so pretty much what I have here already is a bunch of boilerplate, like imports and project setup and whatnot. But like here we come to the actually important part. We just like specify the endpoint of our API, who we are going to talk to actually execute the swaps. Is it an amount for how much we want to swap? And this is like a random Bitcoin address we're going to use later to send funds to. In the end, all that's needed for us to create the swap with Taproot is a simple HTTP post request. And what we say is how much we want to swap from BTC to BTC. We tell the Boltz backend our public key and generate a random pre-image for the payment and send the hash of it to the backend. The way the swap works from a lifecycle and status update wise is that we have a WebSocket now, and that WebSocket pretty much sends the client updates for what the status is of the swap. Similar to how a Lightning payment has different kinds of statuses, in flight, failed, success. These are update messages for the lifecycle and the status of the payment of the swap and what's going on right now. I already prepared some boilerplate for it too, and pretty much all we do is send the WebSocket, hey, subscribe, show me the swap updates for the swap of the ID we just created. So simple enough. And here I have like 3 different lifecycle states of the swap. Like swap created is pretty much like, yeah, self-explanatory, it was created. Invoice settled is where we want to go in the end, which means it was successful. And here we have transaction.mempool, which means that we got the Lightning HDLC and sent some funds on-chain, and these are in the mempool right now, so transaction mempool. And that's what we're going to implement now, to actually create the transaction that claims the on-chain HDLC, reveals the pre-image, and then makes the Lightning transaction go through and sweep the funds in the on-chain HDLC to our own wallet. Yep, that's the plan. I hope I remember it all by memory, and I wasn't prepared on holding a mic, so that's going to be a little bit of a challenge. But yeah. So the first thing we're going to do is we need the music, the aggregated public key. And for that, we need to parse a value from the initial response of the swap creation. Yeah, so we're just going to pass a value that is returned as hex from the initial response as hex. Let me check my notes real quick to make sure I get it right. Okay. Okay, so we pretty much do that. And now we have the public key of bolts of the swap. Then we're going to start by continue with initializing a music. New multisig, and that we await with ckp init, the default. We need our keys. We need a session ID, which is pretty much a cryptographic primitive of how to make sure that we can't replay signatures and whatnot. Hold on, why is my editor so weird? One sec. Better, much better. Just going to use random bytes here. And then we specify the public keys we want to aggregate, which is our public key and the public key of bolts. And now we have the multisig and the aggregated public key. The next thing we'll need to do is we tweak the public key, which means that we make it possible that the public key is not only like a public key, but it also includes the scripts. The scripts we want to execute are called tweaks, and we pretty much tweak the public key, which means we can not only spend via the actual signature, but also via the scripts. For that, we have some nice tooling, and we can just say we want to tweak the music. This is our music. And we want our scripts we call swap tree. Instead of tap tree, we call it swap tree. And with that swap tree, we tweak our public key, our aggregated public key. And the swap tree is pretty much just our 2 scripts. So for that, we use the created response, that swap tree. So now we have pretty much the things set up so that we can spend via 3 different ways, either via signature or via script. Let me check my notes again real quick just to make sure I don't miss anything. So now we need to actually parse a parse the coins, the transaction of the coins being locked on chain so that we can spend them. Like we need to know what we are spending. First, we call it lockup transaction. And for that, we transaction from hex. And this is from the status update we get in the WebSocket. So it's message args0. Let me check again just to be sure. Args transaction.hex. This is the transaction we want to we are parsing and that we're going to spend. A transaction has multiple outputs, and when we as bolts in a transaction, that's not only going to be the swap output, but also change. We want to find the one output that is actually relevant for us for the swap. And for that, we're just going to call detect swap with our transaction. And the value from above, our swap tree, our scripts. So now we know what we want to spend, and now it's a question of how are we going to spend it. We have the three options, the two scripts and the aggregated public key with the common signature. And obviously we just want the cheapest and the most private way, so we'll figure out a way to do a common key path spend with an aggregated signature of us, of our keys, and the keys of bolts. And for that, we'll need to do an HTTP request and tell it what we want to send, like how we want to spend it. And for that, we construct a claim transaction and where we want to spend it to. How much we want to pay in fee, let's say, I don't know, 5,000 Satoshis, should be enough. We don't, no, let's do RBF, why not? Timer blockout we don't need, and it's not a refund. So here we specify what we want to actually spend. And it's first of all, we want to spend the output that belongs to us and belongs to the swap. We want to spend it cooperatively, so we set cooperative to true. We give it our keys, and that should be pretty much it. We also have to specify the type, output type taproot, and yeah, that's pretty much it. Also the transaction hash, which is our lookup transaction.getHash. So we construct a transaction that sweeps the on-chain HTLC to our wallet. Let's call it claimTX. And now how do we get that thing signed? How do we get a common, like a signature for that from our keys and the keys of bolts? For that we have a nice HTTP REST API, which pretty much requires us to give all the required information of the music and whatnot to our API. And what it will return us is a nice signature that we can just use in our transaction and then broadcast it. Just gonna copy that real quick. So we're gonna do an HTTP request. To our endpoint. And instead of an ID, we just put created response.id. And we give it a couple values. Just going to copy that out of here real quick. So our preimage, which is the preimage we have generated above, as hexadecimal. Our pubnonce, which is a property of the music. Double slash, yeah, thank you. I think you also need to do V2. Let me check real quick. Yes.
We'll check first if the code works, then we'll go through it again.
Yeah.
We know it's very fast.
It's very fast, but I don't have much time. And like, yeah, we're gonna go through it again. Serialize the transaction. And index is like what input index it should sign. And for us, we just have one input, so it's 0. Fair enough. For that response, we need to get the data. And now we have like a partial signature of bolts. The last thing that's actually needed now is that we have their signature, we create our signature, pull those two together into a normal Schnorr signature, and then we are pretty much ready. Can broadcast the transaction and are done. And that's simple enough. First in our music, we say initialize a session, which is pretty much what do we want to sign. Let me check my notes again real quick. That's pretty tricky. Yep. Just gonna cheat a little bit here, because that's the actual hard part. All right. So we just initialize a session, which means we tell it what to sign. For us, it's a hash for witness v1, which means take the transaction and we sign it for taproot spent. Then we pretty much say sign partial, which means do our part of the signature. Add partial, which means we add a partial signature from someone else. In our case, that comes from the HTTP response that we just of the request we just did. So from here. Let me check. It's called parcel signature. Parsed it as hex. And now the last thing we need to do, in the claim transaction, in the inputs, in the zeref input, the witness is the music.get aggregate partials, exactly. That aggregates the partial signatures and combines it into one. Now the last thing we actually want to do is broadcast the transaction, for which we also have a nice API. You could use any node, any Bitcoin node, any block explorer, or whatever you have. But for simplicity reasons, we're just going to use our API real quick. Our currency is BTC. We need the hex of the transaction to broadcast it. Yep. And that's pretty much it. That's all we need to do for like a cooperative, multi-sig, aggregated, key path spend. So it might have been a little bit fast, but I don't have much time, and it's really hard to explain while doing it and having the mic held. But like the idea is that once you get the gist of it, once you have like an idea, and we have examples of like one-to-one that code on our docs, it's fairly simple to do. You implement it once and it just works. And the idea is pretty much that you have this one, when we run this code, and I really hope this works now because it would be really embarrassing if it's not. And the idea is that if we run this code, we get a Lightning invoice in the initial response, and if this invoice is getting paid, the WebSocket will get an update. Hey, there's an on-chain transaction for you to claim, and then it will execute all the code we just did. So like, get the transaction that has been locked up with the on-chain coins. Make sure to craft your own transaction that sweeps to your own wallet. Get the partial signature from bolts. Do your partial signature. Aggregate them into the witness, and then broadcast it. So pretty much what you have is a pretty seamless flow that is once implemented, albeit a little bit tricky, and it works beautifully then, because then you can like actually have Lightning invoices that you show around and you receive on-chain. And the same principle applies for Liquid and for Rootstock, that you have pretty much an API that gives you the ability to send from wherever, flaky HDMI cable, send from wherever you want and receive wherever you want. And that's the whole idea of what we are doing and why we are doing it, so that you can like seamlessly bridge between the layers, and yeah, that's the idea. Sure.
Can you explain the privacy risks in all of this?
Yep. When we do these music key path spends, what you see on-chain as an unknowing observer is just like a signature, a Schnorr signature, that has no relation to a swap at all. It looks like a normal single sig spend. The only privacy implications are that a timing attack, like for example, you withdraw from an exchange, like Kraken, and they know this. At 15 sharp, I sent out this Lightning transaction, and at 15 sharp, someone sent an on-chain transaction that was then swept in a self-transfer that could have been a swap. That's a little bit of a privacy risk, a timing attack. And the other problem for privacy is that we as a counterparty, we as an API you talk to, we know that this Lightning invoice belongs to this on-chain transaction. So it's not a perfectly private solution, and I wouldn't advertise it as such. The only privacy gain is from delinking the transfers to the unknowing observer. Like, if you just look at the blockchain, you won't see anything. But it's not the perfect privacy if you want to hide from the NSA.
I know that Rootstock is probably works on like the Bitcoin spectrum for the privacy, but is there a way for you guys to program what you guys do with bolts into Rootstock as a smart contract, and then have that smart contract basically maintain everything that you guys are doing on the back end?
Like, the tricky part on Rootstock is that it's account-based. So it's not like Bitcoin where like address reuse is a bad no-go and you don't want to do that. On Rootstock, you pretty much have to do that on every EVM chain. You reuse the same address for everything you do. Doesn't matter if it's a payment, some smart contract, some lending, you reuse the same address every time. And in that sense, it's worse for privacy, yes. And there's no real way around it. All we do is pretty much, if you want to send on Lightning and receive on Rootstock to your address that you use for everything, that we can do. You can also, like, for example, create a new Rootstock wallet for every swap. You could do that, but like nobody does it. It's super inconvenient, and the whole architecture of Rootstock is built around you have one account, one address, and that you reuse for everything. It's not like a Bitcoin wallet that gives you a new address every time, and it's super annoying if you want to have the principle of one transaction, one address on Rootstock. So Rootstock privacy is actually not that great, yeah. It's not meant for that.
My question specifically was the protocol that you guys have at Bolts.
Yeah.
Do you notice on Rootstock, for example, not Rootstock, but on Ethereum, how you have that smart contract that got shut down by the government?
Tornado Cash.
Yeah,
Yes.
you basically take the bolts to exchange dynamic and things and program it onto Rootstock and have it be that the swaps that are occurring between Bitcoin Lightning is directly programmed into that smart contract.
If you could mix it, I guess one could do it, but like it's tricky legally, and yeah, one could do it in theory. Yeah. Like, we'll have Rootstock in the sense that it's the same as like you can send payments for Lightning and vice versa, but it's not going to be a mixing solution on Rootstock. I hope that answers your question, yeah.
Some reason you guys get down or hacked. And question number two is based on your experience and your current batch, do you actually think that you find out a better way, actually the best cost-efficient way of doing these kind of swaps?
Okay, so the first question is what happens if we get like go offline or get hacked or are uncooperative or whatever you have. And for that we have the scripts. Obviously the key puff spend where you do an HTTP request, we can deny that request and just not return anything or are offline or whatever. And that's what the scripts are for. If you can't do a key puff spend with us together, you can always publish the script on chain and enforce that script. That script is always there. It's like a fallback that if something goes wrong with the key puff spend and the cooperation between the two of us, you can always just publish the script on chain and enforce it. And that's the way we implement it in our software, that first of all, at first we try the cost-effective and the private way, and if that fails for whatever reason, doesn't really matter, we go and enforce the script actually on-chain and pretty much force the transaction to go through. And as long as you can find someone who accepts a valid Bitcoin transaction for like broadcasting, you can execute this thing no matter what. There is no us stopping you from that. And the second question was... Okay, the most cost-effective way of doing swaps, and it's pretty much music too. That's the most cost-effective way because it's literally just a signature that you publish on chain to enforce it, and it doesn't get much more cost-effective than that for Bitcoin transactions because it's the bare minimum of what's needed to actually authenticate that the coins are yours. You can play around with ideas like batching, doing like locking multiple coins for swaps in one transaction. That's something we are working on, but that's not ready yet. But like when it comes to like a single swap happening, music too with like an aggregated public key, a combined signature is as effective as it gets because like it looks like a single sig, costs like a single sig, and yeah, doesn't get much better than that. Sure.
Share this vision of pay what you want, receive what you want. Can you speak to your perspective on incorporating other assets like traditional fiat rails and other currencies like that represent DLC lightning channels or separate assets?
That's a good question. Like for now, we are solely focused on Bitcoin. We only want to be the Bitcoin bridge, so to say, of moving BTC from main chain, Liquid, Lightning, Rootstock, whatever you have. There's surely a market for different assets, like for example, stablecoins. For like you pay RBTC on Rootstock and someone receives a stablecoin in the DLC channel. There's surely a market for that, and I'm certain that someone's going to build that, but that's just not for us right now. Maybe eventually, because for now we're going to focus on BTC and like the BTC wrappers all around, which is already plenty to do. And maybe down the road we'll think about Taproot assets, RGB, and whatever tokens are out there. But definitely an option, and super interesting to think about that you can send from whatever, receive whatever, and it just works. Yes.
So you touched on early transaction batching.
Yeah.
Can you like touch on it a little bit more on how transaction batching would work with atomic swaps in this type of a system?
Yep. What we had in our demo is like a transaction that you have a Lightning invoice. That Lightning invoice is being paid, and we send a transaction on chain. That transaction is going to have two outputs: one for the swap with the agreed amount, and the other one for the change, for like change like normal change for like every other wallet. And batching in that context would mean that we don't just invoice is paid, we send an on-chain transaction, but like we wait for a longer period of time, like I don't know, 30 minutes, an hour, and create a huge transaction that has like a bunch of outputs. One output for a swap of you, one for yours, one for yours, one for yours, and batching in a way that we lock up multiple coins for multiple swaps and multiple users all in the same transaction, which amortizes fees in the sense that it's cheaper to do because you do more in one transaction. That kind of batching.
I didn't get all of it because of all the sound.
Pretty much you do more swaps in a single transaction instead of one transaction per swap. That kind of batching. Do more in one transaction.
But how are you doing that at the same exact time?
That's the problem. You need to have like a very high volume or longer wait times. So which is why we don't have it right now, because we focus on UX, which means instant and as fast as possible. But maybe in the future we're going to have a slow swap that waits for an hour and creates a huge batch for a bunch of people at the same time.
And obviously there would be some privacy benefits.
Maybe. Like it's hard to argue about privacy because there's always us as counterparty and always us who knows the details. So it's not the perfect privacy solution. Okay, so our example here is pretty much the proof of concept, the minimal viable. In a production environment, you would want to save all the values into persistent storage so that you can survive reboots and resets of the application. There's some retry logic and different means of broadcasting. All these things is not in the example. It's like the bare minimum, but like instead of just console logging the created response, you save it into a file or a database or whatever you have. Not that different conceptually.
Have you put integrated bolts into the bolts API into other sites and other projects? Can you touch more on that?
So what we have is our website, Bolted Exchange, and there you can do the swaps. But what we are also really keen on is having those integrated natively into different apps. Like for example, the Breeze app and the Breeze SDK has the send to BTC address option, and that's a swap behind the scenes that goes via us. For example, that, yes. Also on the Ethereum RSK front, we are very keen on having the swaps from Lightning directly integrated into the applications that are on rootstock, so that you can do it natively from where you use rootstock, you can directly swap. And that's something we are super keen on and super interested in and working really hard to make it as easy as possible, that these swaps are not like, I need to go to our you need to go to our website and do it there, but it's actually where you use BTC, there you have the option to actually move between the layers already. No extra step. You can just like select in a drop down where you want to receive, where you want to send from, and it works. It works at the place you actually use BTC and not some separate site you need to go to an extra steps. It's actually there where you want it and need it.
Integration into like commerce sites. Do you all plan to do anything like that, or have you been doing anything like that?
We've mainly been focused on wallets for now, but commerce sites, I think with Saprites and LM Bits, there's a trick. Yeah, exactly. Yep. So, so yeah, TLDR, integrations, yes, mainly focused on wallets for now, but commerce is a really interesting avenue because running a Lightning node for your web shop is a real pain in the ass to manage because that's not your business. Your business is selling stuff and not curating liquidity. So yeah, that's super interesting because then you can receive on Lightning, but actually swap to some cheap chain, aggregate some balance there, and then do a huge UTXO on, go to a huge UTXO on the main chain. All right, and I think that's pretty much all the time we have for today, isn't it? Yeah. Thank you.